In this video, I'm going to show you how to find the maximum value and the minimum value. Okay, here we have to find the maximum value of x sub 1 plus 2x sub 2 subject to these constraints. First step here, we have to get rid of the equality sign and just write equals to. Let's do that here. So let's just get rid of the equality sign and just write equals to. Is to x sub 1 plus x sub 2, which is equals to 10. Is equals to 10, and have 2x sub 1 and plus 3x sub 2 to x sub 2 is equals to 15. Is equals to 15. x1 minus x sub 1 minus x sub 2 is equals to 4. Is equals to 4. Then for this one is just indicating that where we should focus on. So we should focus on the first quadrant. Here is the Cartesian plane, so we should just focus here on the first quadrant of the Cartesian plane. Alright, so now let's draw a Cartesian plane and find the feasible region. Okay. So it's 1, 2, 3, 4. I'll just extend it if necessary. Let me just stop here. Then here is 1, 2, 4, 5, 6, 7, 8, 9, 10, and then 11 here. So now let's plot these straight lines here. Let's just find the intercepts. Intercepts is when x sub 1 is equals to 0, or when x sub 2 is equals to 0. When one of these is equals to 0, we say these are intercepts. Intercepts is when one of these is equals to 0. When both of these are equals to 0 is the point of origin. Okay, so now let's find the intercepts. When x sub 1 is equals to 0, x sub 2 is equals to 5. Is equal to 5. Here we just substitute 0 like this. We just substitute 0. X sub 1 is equals to 0, then plus x2 is equals to 10. Then solve x2. We're going to find x sub 2 is equals to 5. When x sub 2 is equals to 0, x1 sorry man, here I made a mistake here. Here the answer is 5 or is 10, not 5. Answer here is 10. Is 10, yeah. Sorry for that mistake. Sorry for this mistake, man. Yeah, so answer here is 10. Answer here is 10. Then here answer is equals to 5. Then for this one, when x1 is equals to 0, x sub 1 is equals to 0, x sub 2 is equals to 15 over 3. 15 over 3. It's going to be 15 over 3. When x sub 2 is equals to 0, x sub 1 when x sub 2 is equals to 0, x sub 1 is equals to 15 over 2. It's equals to 15 over 2. 15 over 2. For this one, when x1 is equal to 0, x sub 2 is equals to minus 4. When x sub 2 is equals to 0, x sub 1 is equals to 4. Okay, then let's plot these straight lines. I'm just going to use different colors. For this one, I'm going to use green. For this straight line, I'm going to use green. So here is our first point here. This is x2, x sub 2. Then here is x sub 1, x sub 1. Okay, so here is our first point. Then our second point is this one. Then we have a straight line here. And I'm going to shade this area. This is green, 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 green. Okay. Then for this one, I'm going to use yellow. It is yellow. (15 over 3) 15 over 3 is equals to 5. So our first point is here. 15 over 3 is equals to 5. Then 15 over 2. 15 over 2 is equals to 7,5. 7,5 is between 7 and 8 is here. So here is our second straight line. Then I'm going to use yellow here. Then I'm going to shade this area under a yellow line. Then for this one, I'm going to use light blue. Light blue. So the first point is -4. Here we don't consider negative numbers because of this restriction. Because of this restriction, we only focus on the first quadrant. So we know that our line starts somewhere, then it's going to cross here. Yeah, then it's going to cross somewhere here. Okay. Then I'm going to use blue. Okay, so now let's find the feasible region. Feasible region is the area that has all these three colors: green, yellow, and blue. Let's check. This area, is it a feasible region? This one is not, because here we have only green. Then this one, here we have green and yellow. We don't have blue. Then here we have yellow and blue. Yeah, we have yellow and blue. We don't have green. So feasible region is this area. In this area we have yellow, we have blue, and we have green. So this area is a feasible region because we have all these three areas, all these colors in this area, which is yellow, green, and light blue. So this area is a feasible region. Let me just use brown. So this area is a feasible region. This one is a feasible region. So this area is the feasible region. This area is a feasible region because in this area we have all these three colors, which is yellow, blue, light blue, and green. So now let's find the extreme points, the points that are forming this feasible region. Let's find this intersection point, this one, this intersection point. Then after finding this intersection point, we'll be able to find the maximum and the minimum value. Then we are going to solve simultaneously. We are going to solve x sub 1 and x sub 2 simultaneously. Remember, at this point, the blue line and the green line, they are equal at this point. So yeah, let me take these two equations. This intersection is between the green line and the blue line. Okay. So here we have, let me use white. So it's 2 x sub 1 plus x sub 2 is equals to 10. This one is equation 1. Then x1 minus x sub 2 is equals to 4. It's equals to 4. This one is equation 2. So here, let's make x sub 2 the subject of the formula. Let's just use this equation 2. Let's use equation 2. So x sub 2 is equals to 4 minus 4 is equals to minus 4. Is equals to minus 4. Is equals to minus 4 plus x sub 1. This is equation 3. This is equation 3. Then now let's substitute equation 3 into equation 1. Substitute. I'm just going to write substitute equation 3 into equation 1. Into equation 1. So here is x is 2x sub 1 plus, let's substitute the value of x sub 2, which is minus 4, plus x1 plus x1 plus x1, which is equals to 10. Then let's solve for x1, for x sub 1. Let's solve for x sub 1. Let's just open this bracket with this positive sign. It's 2x sub 1 minus 4x plus x sub 1 is equals to 10. Is equals to 10. Here, let's transpose. These are like terms and these are like terms. Two x sub 1 plus 2x sub 1 is going to be 3x sub 1, which is equals to 14. Therefore, x sub 1 is equals to 14 over 3. X sub 1 is equals to 14 over 3. And it's 14 over 3. Then let's just substitute here to find x sub 2. Let's just substitute in this equation 3. So it's x sub 2 is equals to minus 4 plus 14 over 3 Let me just use a calculator here. It's minus 4 plus 14 over 3. Therefore answer is equals to 2 over 3. 2 over 3. 2 over 3. 2 over 3 is equals to 0.6. 0.6. Okay, so let's write these coordinates here. So this point of intersection, we have 14 over 3 and 2 over 3 and 2 over 3 and 2 over 3 and 2 over 3. Let me just erase the information that we don't need anymore. Okay. So here let's write the extreme points. Extreme points are the coordinates that are forming the feasible region. All the coordinates that are forming this shape, this triangle shape. So we call them extreme points. So here I'm going to write extreme points. Alright, here I'm just going to add extreme points. Seems like we don't have space here, man. Let me erase again. Okay. Yeah, I'm going to write extreme points here. Extreme points. these are extreme points here. Let me write the first point there. The first one is this intersection, which is 14/3, which is 14/3, 14/3, then 2/3, 2/3, then here is 0 and 4, 0 and 4, 0 and 4, then here is 0 and 5, 0 and 5, 0 and 5. So now let's just substitute these extreme points here to x1 plus 2x2, 2x2, and let's substitute these points here. Let's start by this one. x1 here is equals to 14/3, 14/3, then plus 2 then plus 2/3, 2/3. Let me just use a calculator here. 14/3, 2/3. The answer is 6. I'm just going to write 6. Then let's substitute these points. Here is 0 plus 2, here is 4. So here answer is equals to 8. It's equals to 8. Then let's substitute here 0. x1 is equals to 0 plus 2 times 5 is equals to 10. Is equals to 10. Therefore, final answer is equal to 10 here. So now let's choose the maximum value is easy to see is this one. So this one is the maximum value, and this one is the minimum value. So this one is the maximum value, and this one is the minimum value. Let me just write here minimum value, then this one is the maximum value. So this one is the final answer. So we found the maximum value and the minimum value. So this one is the final answer.